Why do models deteriorate? Now, this is going to be an interesting tutorial because I can't just simply give you a blueprint or framework here, because there can be literally a myriad of reasons why models deteriorate. Nevertheless, we're going to throw around some ideas so that you can see which way to think when you see deterioration in your model, so maybe you will find the reason. All right, so we saw that a new model in 18 months can easily go from 81% in our rule of thumb assessment to 63%. What could be the reasons? Well, let's have a look at some possible reasons. Additional factors. For instance, your model includes only some variables, and then there is actually another variable that appears that your model doesn't include. A good example would be, say, in a factory, you've got a model that predicts defects, but then you add a new component to your element that you're producing. So whether it's a toothbrush or something else, whatever you're producing, a car. So you've added a new variable, a new component, but that variable is obviously not included in your model because your model was built before that variable was added. Another one could be changes in behavior. So if we're modeling the behavior of human beings, like in the example of the bank, people might change their behavior. Why they change their behavior, that's a different question. It could be a result of something else. So that's like another effect that caused the change of the behavior. For example, when smartphones came out, they became so popular very quickly that maybe people started banking with their smartphones and they don't like the color of your bank's app, or your bank doesn't have an app, something like that. Changes in process. So going back to the factory example, maybe now your toothbrushes are being produced in a different way. So maybe you've changed the conveyor belt somewhere, or maybe you have excluded an additional step from the actual process of manufacturing, and that wasn't taken into account in your model previously, and now it's not performing as well. Changes in existing factors. Going back to the example, we're jumping around with examples here. Going back to the example of customers in a bank, maybe the distribution of ages of your customers changed. So with time, this is a good one. With time, customers get older, and maybe, obviously not as quickly as 18 months, but maybe over a couple of years, your customer base has gotten older and you haven't done anything to maintain that distribution curve as you had when you created the model, and which can be fine. Maybe you're not aiming to get younger customers. Maybe you started as a young bank, a new bank, and then your customers naturally aged over the period of 5 or 10 years, and now obviously their behaviors are different, the distribution of their age is different, and therefore your model hasn't been adapted to the new customer base. So that could be a reason. That's actually a good example because people get older with time, models will also get older, and people's behavior changes, and also the actual distribution of the variable age has changed, whereas the model is expecting a different type of distribution. So there you go, that could be a reason. Maybe a competitor entered the market, or multiple competitors have been entering the market and they have been changing things, or they've been taking a share of your customers, and more customers have been leaving disproportionately more to what the model is expecting. Changes in the industry, that also could be to do with competitors, or maybe say a new product has been introduced in the industry, or maybe there's been a lot of consolidation in the industry, and now there are major players that are that customers are gravitating towards, or the opposite. Maybe companies have broken down into little ones, or maybe there's been acquisitions or mergers or something like that. That's something in the industry. You would know this if you have the intrinsic knowledge and you on top of things, and something changes drastically, or even slowly over time, but still drastically. You would hear about it and you would think that maybe that is causing the changing model. You will know what I'm talking about when you come across it. When you see a change in the industry and you see it affect your model, or you see a change in your model, you will link the two. It's sometimes very obvious when this happens. Changes in regulation. That's a good one because it can actually really impact a model very quickly. Let's say something changed in the regulations overnight, and now a process has changed. The way you do things has become different. For instance, previously, in order to get people to perform an action, which you're measuring with this model, you had to send them direct mail. So you had to send them physical mail to get them to do something. Let's say it was to get their phone number. You don't have their phone number and you want their phone number, and this model is predicting the likelihood of people giving you their phone number. So previously, according to regulation, in order to get their phone number, you had to send them direct mail physically. But now the regulation has changed and you can send them electronic direct communications, right? EDMs, and they can reply by email and give you their phone number that way. Of course, it's going to be easier to get their phone numbers, and therefore your model is not going to be performing as well because it's not used to this drastic change. It's built for direct mails, or direct communications. Now you're sending electronic direct communications, completely different situation. You have to rebuild the model. Changes in product. That's another one. Maybe you're predicting how likely people are of uptaking a certain product, and then you release another product which is cannibalizing the demand for the first product. So you're kind of competing with yourself, and the model doesn't take that into account. So the model was built in the circumstances. What we're trying to understand here is that, or the message I'm trying to convey is that a model is built in a certain environment. It is nurtured, grown, and deployed in a certain environment. If the environment changes, then the model might break. It might stop working. These things are very fragile. They can only work. They're very powerful and strong when they work in the environment where they were created. As soon as something about the environment changes, the models can deteriorate and even break. Depletion. That's an interesting one. If a model over time has used up the customers or the elements that it's modeling, so it's kind of a vicious cycle here. So it doesn't apply always, doesn't apply to almost, only some situations. So when, say, you want some action which is a one-off action, you can't get that person like a repeat purchase, or you don't even need to get him to do that action. It's like the example of providing a mobile number. Once you have the mobile number, that's it. That person's out of the equation, and perhaps your customer base is not growing that quickly, and say you created a model on a small sample, like 10,000 people. You created this model, and then you want to apply it to your whole population. Well, after you've applied it once and you've sent out the communications to get those phone numbers, and you've gotten them from the most probable people to give them to you, that's it. If you apply the model again, your population has changed, right? You're not going to apply it to those people that already gave you mobile numbers. You're going to apply it to those that didn't, and therefore your model is not going to perform the same way because you've already depleted that potential for people to give you mobile numbers, which is actually a good thing. So you've actually gotten the phone numbers. Just the thing is that you can't reapply the model in that case. So situations like that can occur. Be careful of those. And number 10, what I think of here, spontaneous changes. Okay, this is an interesting one. Something in the industry, company, behavior, regulations, product, any of these happened like very, very quickly and unexpectedly. And why I brought this one up, because I wanted to show you as a bonus 2 additional examples of model deterioration. These are going to be a bit weird, and they're going to be funny, and they're going to be a bit challenging to understand. So let's go ahead. So example number 1 is this one. What do you think happened here? What does this look like to you? It looks weird, right? It's you wouldn't think that the red line can be both above and below the blue line. But let me explain what happened here. And I'm going to use my mouse for this because this is important. So when you see something like this, obviously something happened, something went wrong. It's not just like gradual deterioration like this over time. This was like a spontaneous kind of thing. So what actually, in fact, happened here is the way kind of to determine this is look at the area under the chart. Remember long time ago, a couple sections ago now, we were talking about the correct mathematical accuracy ratio is defined as the area under this model over here divided by the area under the perfect model, which we can't see over here. And what we're using is just a rule of thumb because it's faster and it's very visual. So look at the area under the curve here. What do you see? You see that the area under the curve has decreased, right? So there's a less area under the curve. What this is telling us is that the model is not predicting as many churners. And in this particular case, what exactly happened is the number of churners drastically increased. And if you, this might be a bit weird to look at it this way, but look what's happening. So the model's predicting, still predicting, even though it's going under the blue curve, doesn't matter. It's still predicting that people are leaving. So as this is growing, you're growing here. So as long as you're going up here, that means you're getting more churners or more people that actually left. And so as it gets over here, then you have this drastic move, bam, very quickly. So basically here, every single time you take a person from the horizontal axis, you're picking up a lever, an actual churner. Then you pick up another person, he's also a churner. So here, it's every single time, it's spot on, you're hitting a person that's leaving. And then it starts predicting again with some sort of rate. So what this is telling us is that before, it looked like this. Before, there was just a normal curve here. So as you were picking up like a certain number of people, some of them were churners, some of them were like people who left the company, some of them weren't. But here they all became leavers of from the company. So what this is telling us is there's something drastic change in the industry, that all these people that used to be here now all of a sudden have left, or all of these people that all this classification, the people that were placed here according to the model's classification have now left. A good example of that is a categorical variable, like let's say country. Let's say we have 3 countries, right, in our data set, and let's say all of these people are from Germany, then these people are from France, and these people from Spain. Of course, the model doesn't do that, but if there is a very distinct difference between the regions, they might end up grouped together. So if everybody from Germany is much more likely to leave than people from France, and they're much more likely to leave than people from Spain, then that's how the model is going to structure it. So the logistic regression will put people from Germany at the start, then people from France, and people from Spain. And then what happens here? Everybody from France decides to leave the bank. That's it. Maybe that's a good example of change in regulation. Maybe they're not allowed to bank with your bank anymore. That's it. Your bank has been prohibited of working in France. Everybody in France is going to leave your bank. And that's what we're seeing here. That's why as soon as the model gets to the people that it previously placed in this part, which were all from France, and were kind of like at moderate risk of leaving, now they're all leaving spontaneously. And as you can see, that is blowing up the model. So what would you do in this case? Well, first of all, if you know the exact reason and you can see that there's this categorical variable, of course you would exclude it from your modeling, because you would treat them separately. You would treat the population of your bank, or the people that bank with you in France, you would treat them separately, because there's no point in modeling them. They're all going to leave anyway. You already know that. What's the point in putting them in a model? If it's not such a drastic change, you just rebuild the model, and you would try see how that can be accommodated by the model. The other one we're going to look at is also a bit weird. What do you think happened here? And this is a great example actually of the fact that you can't always use the rule of thumb. You can use the rule of thumb when models are like normal, like that. When this happens, look at this model. So here you can see that at 50%, this is, by the way, this is the same model. This model is the same as this model. And what you can see here is that at 50%, this model is actually predicting a lot more. So like nearly 89% of churners. So this rule of thumb assessment has gone up really well. So this looks like a much better model if you assess it that way. But what is happening in reality is, if you get over here, you see the model's predicting. And then once you get over here to these people that were placed somewhere between 60% and 80%, so you get to these people, you're not picking up any levers. None of them are actually leaving the company, or none of them are performing that action that you're measuring. So similar to this situation, but the opposite. Here they all decided to leave. Here everybody in France decided to stay. Once again, could be a regulation, could be a new product, could be maybe there were only 2 banks in France, and one of them just closed down, and that's it. You're the only one, so everybody had to stay with you. It could be anything like that. But once again, in this case, something major happened, and you can see that your model broke. So in this situation, I wouldn't measure it with this rule of thumb. In fact, I would do something about this categorical variable because it is definitely doing something wrong to the model. And also you have to rebuild or retrain the model.
Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.